It takes 7 years for $2,000 to double when it is compounding continuously in an account. Find the interest rates. We first have to identify which formula do we use. And we learned these two formulas in Unit 7 when account is compounding continuously. And so we're going to use A equals P E to the RT. A is the amount in the account at any given time, T. T is number of years. P is your principal, what you initially invest. And R is a rate. And the rate is going to be as a decimal. We can convert it back into a percentage. So let's get started by inputting numbers. It takes 7 years. So I know that T is going to equal 7 years for $2,000 to double. So we're going to invest $2,000. That's the principal. And the amount at the end is going to double. I'm taking it times 2. Let's put that information in. 4,000 equals 2,000. Remember, E is Euler's numbers raised to the RT, and my T is 7. Now, the reason we learn about logs is so that we can solve for a variable that's in an exponent position when we can't do mental math. So I'm going to start by trying to isolate the E. I'm going to divide both sides by 2,000. 4,000 divided by 2,000 is 2. Now, it would be great if I could get rid of that E and I could move the RT down to the same level. Again, that's why we learn about logs. And so I'm going to take the base of this, which is E, and I'm going to write log base E to both sides. I do want you to recognize that log base E is the exact same thing as ln. So you can also just write ln instead of log base E if you prefer. On the right-hand side, we've learned about the properties of logarithms. This exponent can be dropped in front. So I have RT goes in front, and I have log base E to the E behind. Now, I'm going to take a second and just review, since we've had a weekend, review this concept. If I said to you log base 2 of 2, what does that mean? It means what value do we have to raise 2 to equal 2? So 2 raised to what value equals 2? And the answer is 1. As long as this value, the base of the log, is the same as the number behind it, this will always equal 1. Every single time. So I have RT times 1, which is simply RT. My goal is to solve for the R, and by the way, my T in this problem is actually 7. So I meant to put a 7 here. Let me go back here and change this to a 7. So in this position right here, I really have 7R, or R times 7. Now I'm going to divide both sides by 7, and what I get over here is going to be my rate. How do we plug this in? Remember, as I stated earlier, that log base E is the same as ln. So there's a shortcut key. Go straight down the left-hand side, and you'll find the ln button. So ln of 2, enter, and then I'm going to divide it by, why did I put an R here? I meant to put a 7. I'm really not feeling well today. Divided by 7, and then I'm going to write this down. 0.09902, and we're going to round to the nearest tenth of a percentage. So I'm going to move this 2 places to the right, and I have 9.9%. That's the rate in order to double within 7 years. All right, so students in class have a chance to try this problem on their own. This says we start with $500, that's our investment, our initial investment, and it turns into $1,500, which is tripling after 18 years of continuously compounding. How much was in the account after 10 years? So our first job is to figure out what is the rate. We know it's continuously compounding. We end up with $1,500 after starting with $500. We don't know the rate. We're going to come back to this in just a second. And after 18 years, this fact occurs. So just like the first example, I'm going to start by dividing by 500. 1,500 divided by 500 is 3. And I'm going to do the exact same steps I did in the first example. So I'm going to do log BC, which is the same as ln. So I'm going to do ln to the left and to the right. The R times 18 is going to drop in front. R times 18 drops in front. And over here I have the ln of E. ln of e is like the same thing as a log base c, so this is going to simplify to 1. And whether you write r times 18 or 18r, it's the exact same thing. I'm going to divide by 18, coming back over to the side, and I have ln of 3, and then you have to press enter, and then divide the entire quantity by 18, and I'm going to write this down. I have 0.06103, and so on. Now that's my rate. Now as a percentage, we would say 6.1%. 1 second. Whenever I plug the rate into the continuously compounding account, I do need to put it in decimal form. So let me rewrite this equation. We don't know how much is going to end up in the account, but we know we start with 500, and we know we have a rate of 0.061. I'm just going to do 3 places after, so the thousandths I'm rounding to. And now we want to evaluate this after 10 years. So I'm going to take the right-hand side and I'm going to substitute in 10 for the t. How do I plug this in? 500 times e raised to, and in parentheses I have 2 things, so 0.061 times 10, and here's my answer. $920, and we're going to round to the nearest hundredth, and 22 cents. All right, if you're live in class with me and you're feeling confident, just continue working through it. If you're feeling a little bit confused, let's do this together. So this is the initial deposit. We know it's being compounded continuously in an account, so I'm going to rely on this formula. The initial deposit is $3,000. It gains $500 in interest, so your end amount is $500 more than your initial amount. So 3,000 plus 500. Now, how long does that take to occur? It takes 6 years to occur. Time is always within years. So the first thing I want to do is I want to figure out what is the rate. So I have 3,500 equals 3,000 e raised to the 6r, or r6. I'm going to start by dividing by 3,000. And 3,500 divided by 3,000 is 1.6. Now what you do not want to do, please listen, you do not want to round your decimal and then continue to work through it and then round at the very end. So I have to find a way to rewrite this, and it needs to be in simplified form. So I tried it and did not get a nice terminating decimal. So I'm going to hit math, fraction, enter, enter, and I'm going to write it as 7/6. That's an exact amount on the left-hand side. And just like we did previously in example 1 and example 2, now in order to solve for r, this is the reason we learn about logarithms, I can either write log base e or equivalent ln. ln of 7/6, ln of e raised to the 6r. Again, this property of log says that the exponent is going to drop in front. And I have 6r times the ln of e equals ln of 7/6. ln of e simplifies to 1. And now to solve for r, I'm going to divide both sides by 6. It's very important that first I evaluate the top, and I have it in parentheses, and then I divide by 6. So it's going to look like this. I have the ln, and it's already has a parentheses, 7 divided by 6. I'm going to get an answer by pressing enter, and then I'm going to divide it by 6. 0.02569, and so on. So what is the rate? The rate is approximately 2 point, and now I haven't been told what to round to, so if you put 2.5, fine, or if you put 2.56 or 2.57, depending on what it tells you to round to. I'm going to say 2.56 to be a little more exact. Okay, so let's go up here and let's rewrite this. I have A equals, now my initial amount is 3,000, and I know that my rate is 0.256. So 4 places after I chose to go to, but nothing's told me exactly what I have to round to, so that could be a little bit confusing to you. The more you put, the more accurate it's going to be, times t. Well, what is this question asking? It says, how long does it take it to double? So if it doubles, if I take this times 2, my end amount would be 6,000. So 6,000 equals 3,000 e raised to the 0.0256 t. I'm going to start by dividing by 3,000, and that's how I end up with 2, because it doubled. And the procedures I'm going through are just like any other problem that we've done today. I'm going to take the ln of both sides, and the purpose of that, it allows me to isolate the t. So this amount's going to drop in front, 0.0256 t times the ln of e equals ln of 2. ln of e doesn't just disappear, it simplifies to 1, and now divided by 0.00256 to both sides is going to isolate the t for me. So I'm going to start here with ln of 2, so ln of 2, enter, and then I'm going to divide it by 0.20256, and it looks like it's right around 27 years. T is in terms of years, right around 27 years.